Okay, so now we're ready to put the wiring schematic together for this and get the plan in order. And right about now, you're probably thinking some of this seems like overkill. But I wanted to go through the steps on a project that wasn't super overcomplicated. And I figured this one wasn't too complicated to follow and would have all the steps we need. We won't need to do any complicated math to get the electronics together. So lately, I've been using this online schematic editing software called Easy EDA. You can just search for it in Google, but the address is easyeda.com. Just come on here and go ahead and log in. I have an account. If you don't have an account, it's free to set one up. And this will handle the schematic software and the PCB or SMT design. So I apparently have to go through some reCAPTCHA stuff. Convince that I'm not a computer. Well, I'll pause the video while I do that. Okay, I had to click on some pictures of crosswalks there. But eventually get logged in, or you can just set up an account. It's free to set up. And one nice thing about this is it will handle the schematics and the PCB designs, or SMT, that's surface mount. PCBs are the ones that we can kind of solder by hand, whereas surface mount, those are the ones that we basically have to have a machine do. The two types of circuit boards, but we can generate them right from our wiring schematic with this stuff. And this is created by a very well-renowned PCB SMT manufacturer, printed circuit board manufacturer called JLC PCB. And when we finish, if you use this software, as soon as you're finished, you can order it straight from their factory. So it's like design the schematic, transfer that to a PCB diagram, and then order the PCB right from this same software. So we need to come up here and create a new project. So a new project, and I've called this basic control unit. A replica of an old NES style controller to work with educational video games, as well as general mouse controls. Hopefully an ergonomic design. In the end, but that's still a little ways to go. Oh, whoops, misspelled controls. So just give it a name, a basic description. When you hit save, it'll go ahead and generate the starting point. Don't need these little tips. But you can see we have this schematic diagram, some buttons to connect things, and over here is our library of basic components. So right now this folder doesn't really have anything in it, just this basic schematic. We'll save in a second. We can pull up the basic components and just select the one you want and then click over here to put it somewhere. Right click to undo that, and then you can drag it around the diagram, and we can make connections by grabbing a wire, connecting that, bring it over to something else. And I'm going to go ahead and delete this stuff for now. And you can see it's just a click and drag interface to put the schematic together. So what do we have? Looks like we'll have an Arduino Nano. So if we go over to the library button, we can search for the parts we have. Arduino Nano. Whoops, that's not how to spell nano. Let me correct that typo. Arduino Nano, I think it found it anyway. But as we search through here, there's a couple different ones. We'll need a piece like this that has the schematic. See all the connections so we can hook up the wires, hook up the various components in the schematic, as well as a footprint for the PCB or SMT design. So I'll go ahead and use this basic one, click place, and just stick that in the middle somewhere. And I'm going to turn this sideways to match what is on the board. So up here we have some rotation controls, rotate that left. And then on the initial markup, I had the nano in the middle, four momentary tactile switches to the right of it, and a 2-axis joystick to the left of it. So I'll pause the video while I bring in those other components, and I'm just going to do the same thing. I'm just going to search through the library and find some pre-made ones to put into the schematic here. Okay, so I got all the components in here. Search for an Arduino Nano and a 2-axis potentiometer joystick. And then momentary tactile switches are one of the basic components. And for this connection, all of this will work with 5 volts, so we don't need to add any resistors or anything to adjust our current. We don't need any complicated electricity, but we will need some resistors for pull downs on the momentary tactile switches. We'll talk about that in a moment. So first off, the connections. And to connect things, we can just draw a wire to connect it, or we can set up a bus to connect it. I'll just do it all with wires in this case, and then put some labels on them, just to kind of keep it simple. So I'm going to put a 5-volt rail up here at the top. I'll just come up a little ways, click this, come over here somewhere, get the end of it, and notice when I bring it in here, it's going to try to connect to that, and I can drag it all the way down that way, and just have a 5-volt rail somewhere across there, and I'll bring in a label, a little flag to label it with, and you see these pieces should be connected now. So if I drag that flag around, it stays with that bus wire. It's very much a drag and drop software. I'm gonna do the same thing for a ground here. I'll come out one of the ground pins on the Arduino Nano. Just come down somewhere around here, come over to the right. That way, whoops, undo that one. Let's try that again. I just hit Control Z to undo that. So come down a little ways, then over to the right. Make a nice little straight line there. Now come back, reconnect to this junction, and drag it out this way. That way all of the components are close to either a ground or hot rail. We can cook everything up that way. Just left click to make the selection and right click when you're finished. And I'll put a little flag down here to label what that rail is. That way we can tell. And then we can just set up wires to form all our connections that same way and kind of plan out the thing here. And while after labeling those lines, I'm noticing probably could have relabeled all these components. So I'm going to do that. I'm going to start here. I'll select the 2-axis potentiometer joystick, and over here and give it that name. So the prefix U2, we'll need that to stay the same. So that's unit number 2 as far as put in there. Unit number 1 is the Arduino, and then we have the key 1, key 2, key 3. The general labeling, schematic labeling for what component it is, but it's also helpful to have good names on them. So I'll come up here and label this as a 2-axis joystick and just change the name position. That way we can tell what's what. Arduino Nano is good. And I'll go through and label these buttons the same way. There's no need to watch that in the video, so I'm going to pause that and I'll be right back. So let's get started with the buttons over here, the action buttons. So I labeled them yellow, red, green, and blue because eventually we'll put some plastic caps on them, and that way you can tell which one's which. So if you're not familiar with these, basically the idea of how we wire these up is we bring voltage into one side of them. So I'll just connect to the rail over here. And then when the button's pushed, it will connect to this other side. So we can choose either pin on this side. It's best to do the pin that's not directly across from the voltage source in. And bring this over to one of our digital inputs. So I'll bring this yellow one over to, let's see, I'll use 4, 5, 6, and 7. That'll work. So digital pin 7, which is the 10th pin on the Arduino. So bring in the yellow action to D7. And then one other thing we want to do with these is it connects it and feeds back, and then we'll read that voltage whenever that connection is made. But if that connection is not made, we want to do something with that electricity. We don't want to just leave it open and floating there. So for that, we will want to bring a resistor in. And let's see, I'll rotate this to face the right direction. And then I'll come into that resistor and then right back to ground. So that way, if the button's not being pressed, the voltage just comes in and right back to ground and doesn't float and do odd things on us. We know it's going to flow right back to ground until we press the button, at which point it'll float on this line, and then we can just check this when we get to coding it to see if there's a voltage on this line or not. And we'll hook all of these buttons up the same way. So I'll go ahead and pause it and make all those connections. Pause the video and make those connections. They will be the same as this. So 5 volts coming in, and on the same side have a pull down resistor just to dissipate that electricity if we're not doing anything with it. And then on the other side, send that to one of the digital pins to be read. And should probably mention real quick about this pull down resistor. There's a trade-off between the speed we get and the amount of noise that comes through. The general good starting point rule of thumb is start with a 10 kilo ohm resistor, and then adjust that as needed to filter between the speed and excess noise. So I'm gonna label that as a 10K resistor. Okay, got those hooked up, and I did make a slight change. Originally I had the yellow action button connected to 10, and when hooking it up I decided, well, for now it makes more sense to have left to right on the pins match up left to right on the buttons. But as I mentioned earlier, with the breadboard, the original Mockup, we're restricted on the orientation of the Nano. But when we order a PCB, I plan on turning that Nano vertically, and so there's still some modifications to do on this later. And when this turns vertical, it's probably going to be a lot easier to avoid these crossing lines. So there's still some cleanup, but we can see all the connections made and just kind of getting a start on everything. So now we need to do the same thing with our 2-axis joystick. So we'll grab a wire, come out the ground pin. Let's come up and over and back down to the ground rail. So notice when I clicked to that other wire, the connection was finished. So now I'll come over, do the same thing for the hot rail. Bring that up to the 5-volt rail, and it connected. And on these, you can kind of draw a wire and see how it keeps trying to draw. If you right click, it'll stop drawing it. So I'm going to hit Control Z to undo that one. And then I'll bring the X and Y outputs from the joystick over to a couple of analog inputs, maybe A3 and A4. That'll be a start. This can all be adjusted later. Right now, just kind of getting a start on the idea of what needs to be connected. So that should be good for the connections. So I'm come up here and hit File, and save the schematic here. So that's saved, and we'll probably could put some labels and stuff down here. I'll do that, worry about that in a later version. Another thing I wanted to show about this, so now we have that sheet, the initial sheet, probably rename that to something better later. But once we have a sheet, we can just generate a PCB diagram right from this, ready to send off to the factory. So let's look at that real quick before we go start hooking up wires, and then we can come back and do all the cleanup later. But I found over the years, it's useful to go ahead and get started along the way and think about all the connections while doing this, and that way when we get to the board and actually hook them up, we've already done a whole lot of the thinking and a whole lot of the documentation is ready. So once we're finished with the schematic, which this one isn't quite finished, I just wanted to show the button, we can go to design up here and hit convert to PCB. And right now it's not happy because some of these wires are just open at the end. I'm going to go ahead and hit no, keep going. We'll come back and refine this later. And this will just generate our PCB diagram. Looks like a good start. Hit apply. And you can see down here, well, everything's a little bit off size. I'm going to select that and move it all down here somewhere. So it brought in those components we put together along with the connections that were made. So now we can just set up the traces so the routes that the electricity will flow through the printed circuit board, which we will come back and look at later. I just kind of wanted to do a quick preview of it now. We'll come back and do that. There's an auto trace button where we can just have the computer go through and figure out a route for each one. Or when we come back, I will, in a later video, I'll trace through and we'll set up the traces manually. And just, we have all the connections and all the components, which are good for either a PCB with the holes that we can solder things into, or the SMT's surface mount technology with the pads that a machine will do those very fine soldering points on just one side of the circuit board works. But we'll come back and do that later. I just wanted to preview the buttons. Once we get that in there, I'll go ahead and hit File and Save for now. Definitely not finished. But once it's finished, there is but we can come over here. Well, if we're going to do it SMT, we have to fill out a bill of materials so that the factory will know what components to stamp on there for us. Or we can go ahead and get the Gerber files for the PCB fabrication. Keep going. We're going to come back and do this later. Design rules. No, keep going. We'll do all that stuff later. You can see eventually it has the print PCB and the order. It's ready to order. You know, have an order button as soon as it's finished going through this way. So that's one nice thing about this software. But we will come back and do that PCB once we get the schematic fixed. So I'm going to go ahead and delete this. And we'll make a better one later. Okay, delete that. This looks like a good start to the schematic. I'm coming here and change this to the proper name. CSF controls. That's the name I compose my hobby projects under. Basic, control unit. I have to be careful typing and thinking at the same time. Typing and talking at the same time. I'll try to say something different. So CSF controls, that's just my initials. That's what I put all these together under. And this is the basic control unit. Put that on the sheet. I guess I could do this a little bit different. Could put basic. Where's my cursor? There it is. Put basic control unit. And for the company, I'll put CSF controls. Drawn on this date by this person, sheet 1. That'll work. Kind of gets us a start. And we can come up here and go ahead and export a PDF of this. Oh, save first. File, save. And now file, export a PDF of this to include in that documentation. PDF, one sheet, be colored and everything. So go ahead and export that. And we have a schematic, this schematic to go ahead and include in the documentation for our project. Even though it's not the finished version, but if we build the documentation along the way, it's a whole lot easier when we get to the end. But now we're ready to actually make all these connections on the circuit board. And like I just mentioned about building the documentation along the way, that PDF that was downloaded, even though it's not even close to the final version, I went ahead and stuck that into the documentation for the project on the page for schematics. Maybe wiring, that label might change later, because technically that's the only schematic on this page right now. But even though it's not the final version, go ahead and build the documentation along the way. That way you don't get stuck with the only boring stuff when you get to the end. So now let's go hook up the wires in this fashion that we just planned out here. So the first thing I did here was just make sure everything could fit in the breadboard. The big problem was this wire here. It'd be a whole lot nicer if that nano could be oriented that way on the breadboard, but for the initial mock-up, we're kind of restricted to going across that groove in the center. That way we don't short anything out. But the cable wanted to be too long to fit all the buttons in there, but I think got it all fit on one breadboard. So I have the 2-axis joystick over here, the action buttons over here, and the controller in the middle. So now ready to hook all of this up. And here is those connections made like we just planned out. So here on the breadboard, I did all the power connections with just some regular jumper lines. Each of the switches has a 10K pot on a pull down resistor, and then a wire running over to the digital pins for inputs, just like we planned, and the X and Y axis of the 2-axis potentiometer running to analog inputs A3 and A4. Everything's set up, should be able to reach all the buttons okay when used, so I'm going to put the plastic pieces on here, take a picture for the documentation, and then get started coding this up. So like I just said, snapped a picture and put some labels on here for the instruction manual page of the documentation, which again, yeah, for something like this, it's kind of overkill, but I wanted to go through all the steps of doing this properly, seeing all the parts that need to be included when putting a project together. So kind of overkill on a simple thing like this, but a project where you would need to be very careful at all the steps would be very complicated to follow along with. So I wanted to do it on a simple project as well. But the labels and then that labeling will apply to the instructions later. So now we're ready to jump into the code and get this code reference section of the documentation filled out as we put the code together, the same way we've been doing the documentation, just along the way. That way we don't finish the fun part and get stuck with just boring part at the end. And might as well throw this in the video real quick. So here's just the plastic caps put on there. But same thing we just looked at. You can see the color coding on the wires matches the plastic caps. The orange on the X-axis control and the purple on the Y-axis control to make troubleshooting this together for the original mock-up a little bit easier. All right, so now let's get started coding this up. So as I get ready to code, I've also started thinking a little bit about what the final version might be. So obviously with a game controller, first thing that comes to mind is this basic shape where I have the buttons on the right hand organized where it can be held comfortably, hit all the buttons, while the left hand twirls the joystick around. But I'm also wanting this to be used for mouse control. So another option I have is a one-handed, almost like a trackball mouse, sort of, with 4 buttons positioned as it would be on my finger, maybe some sort of comfortable rest position. Then my thumb can move the joystick back and forth and my fingers are right above the buttons. So just starting to think about those as well early in the project, and that way have a lot of options to choose from by the time we're ready for the actual layout on it.